After completing this lesson, you will be able to link components to the design, use joints and as-built joints to position components, and create a pattern of components. For this lesson, we need to use the New Design from File tool to open the F1 Car Complete Body Fusion Archive file. Before we can link other components into this design, we need to make sure that the current components in this design are being held in place properly. Since the car body is the primary element, I'll go to the car body, right-click, and select Ground. This will prevent the car body from being moved. Selecting the rear wing or the front wing, you can see they're still able to move. I'll undo that change, and then we can constrain those components. It's important to take a second and discuss the fact that Fusion 360 only applies joints to components. Had you modeled the front wing or the rear wing as bodies, they could not be assembled using joints. There is an align tool that can help you make sure that things are in position, but that's not a joint. Since these components were modeled in the correct position, in fact, we use them to cut the clearances directly out of the car body, I'm not going to bother using a regular joint tool either. Under the Assemble pull-down, I'll use the As-Built Joint tool. That will allow me to select the rear wing and the car body and apply a rigid joint or any other type of joint. If these were going to spin, I could apply revolute or slide across each other. Spin and slide will be cylindrical, and any other standard joint can be applied using as-built joints. We'll click OK and start the tool again and do the same thing for the front wing. Notice that I'm selecting the non-grounded component first. Even though it doesn't matter with as-built, it's a good habit to get into so you don't accidentally move things out of the way when applying joints. I'll click OK, and now everything is held in place inside of our model. Before I'm able to insert any components, I need to make sure to save my work. I'll save the file to the project, and then I can expand the data panel, go to the project and folder where I uploaded the data previously, right-click on the wheel assembly and say Insert into Current Design. After a moment, the wheel will appear in my assembly. I can move it out into open space if I like, or I'll just click OK. Now I'd like to use the Joint tool to apply a joint between the wheel and, in this case, the front wing. Notice how the car body fades out as soon as I start the Joint tool. That's because it is grounded and cannot be moved, so it's not an option to select as a first component in a joint. I'll hover near the front curved edge of the wheel, and I'm able to select the joint origin that's at the center. Zooming in on the front wing, it's ready to select the second component. As I hover over this face, you'll see there are a large number of options. The dots represent endpoints, triangles represent midpoints, the square represents the centroid of the face, and the cross represents the center of the arc. That's what I'll select. It goes into place aligning the center of the wheel. I'll change this to a revolute joint just for sport, but of course it's not going to work very well where it's located. So I can drag this joint out into the open space. In fact, I can even drag it out and align it with the side of the front wing. You'll also notice that only the wheel and not the bearings moved when I started to apply the joint. That helps to cut down on resources if you start placing joints on large models. When I click OK, and the wheel assembly will be properly located. I could insert another wheel assembly from the data panel, but instead I'll go to the browser, right-click, and do a simple copy and paste. This will put another instance of the wheel into the assembly, and we'll start the joint tool to position it as well. This time, we'll select the other side of the front. Using the same technique, you'll see that it comes in backwards, so we can use the flip tool, and then locate it based on the face. Click OK. Now we have our two front wheels. We'll go back to the data panel one more time and select the axle and insert it into the current design. It will come in, and I can rough this into position just to make the selection a little easier. Let's apply a joint to it, and even though it's not technically mechanically correct, let's go ahead and just lock this in place with a rigid joint. Now we have our front wheels in place. Under the Create pull-down, I'll select Rectangular Pattern. I'll set my pattern type to Components and select the two wheels and the axle. For my direction, I could select the Z-axis and then start moving parts into place. The proper distance for the wheelbase will be -97.5, but I only need 2 sets of wheels. I don't need a third one, so I'll reduce the number in the dialog or in the mini dialog and click OK. Now when I go back to my home view, I have all of my components in place. The front wheels are properly constrained. The rear wheels were positioned based on a pattern. This puts them in the right place, but they are not constrained. To remedy this, I can create another as-built joint between this wheel and the car body, making it revolute about the center of the wheel. I can repeat this process for the axle and the other wheel, but instead I'll use another assembly technique called Rigid Group, where I'll select this wheel, the axle, and the other wheel, and say that they are always connected as they are now. So if I move one, the other moves. When I'm done placing my joints, I can turn the joints folder off and shut off the visibility of the joints, and go ahead and save my work.